In this video, we are going to calculate the Fourier transform of a train of impulses. Train of impulses means we have a unit impulse function which exists at t is equals to 0. So that means the function will give value at t is equal to 0 only. Train of impulse means there are various impulses which exist at t is equal to 0, t is equal to capital T, 2t, 3t and so on. Similarly in the negative side, at t is equal to minus t, minus 2t, minus 3t and so on. So this way continuous impulses are existing. So this is basically a periodic signal. So whenever we are having a periodic signal, we cannot calculate the Fourier transform directly. First we have to calculate the function ft. Because it is a periodic signal, we have to use the Fourier series. So for the Fourier series, the function f of t can be calculated with the help of this formula, which is n is equals to minus infinity to infinity Cn e raised to the power j n omega naught t, where you have to calculate the value of Cn, which is nothing but 1 by t minus t by 2 plus t by 2, the function ft, e to the power minus j n omega naught t dt. So this Cn we have to calculate for all the functions which are periodic functions. So this periodic function is impulse function, which is delta tt. That is because it is a train of impulses, so I have used the suffix t. So delta t is equals to summation n is equals to minus infinity to infinity delta t minus nt. So for various values of n, you will be getting delta t plus 2t, delta t plus 3t, delta t minus 2t, delta t minus 3t and so on. So all the positive values and all the negative values will be considered in this particular function. So first now we will calculate the function Cn. So this Cn, the limit of integration is minus t by 2 to plus t by 2. As you can see, minus t by 2 is somewhere here and plus t by 2 is somewhere here. So between minus t by 2 and plus t by 2, how many impulses are there? Only one impulse, which exists only at t is equals to 0. So at t is equals to 0, so that function you can write it as delta t is equals to 1 for t is equal to 0 and 0 elsewhere otherwise. So that means within the limit minus t by 2 to plus t by 2, you are having only one function which is delta t, which gives the value as 1. So you will put ft is equals to delta t and e to the power minus j omega naught t. So within this value, delta t gives you the value as 1 and it is at t is equals to 0. So if you put t is equals to 0, e to the power 0 will become 1. So overall this integration will become 1. So Cn will be nothing but 1 by t. So this way we can calculate the value of Cn for this particular function. So now this Cn value we will keep in this ft. So your ft will become 1 by t summation n is equals to minus infinity to infinity e to the power j n omega naught t. This is your ft. Now we will calculate the Fourier transform of ft. So Fourier transform of ft is nothing but Fourier transform of 1 by t summation n is equals to minus infinity to infinity e to the power j n omega naught t. Now we already calculated the Fourier transform of e to the power j omega naught t, which is 2 pi del omega minus omega naught. This we have already calculated. So if instead of j omega naught t you are having j n omega naught t, so this omega naught will become n omega naught. Only omega naught is multiplied with n, so your transform will be 2 pi del omega minus n omega naught. So the Fourier transform of ft will be 1 by t and then the Fourier transform of this is 2 pi del omega minus omega naught. So this is 2 pi by t del omega minus n omega naught. So 2 pi by t is nothing but omega, where 2 pi by t is omega naught. So instead of 2 pi by t we can write omega naught del omega minus n omega naught. So this is what the Fourier transform of train of impulses. So this is how you can calculate the Fourier transform of various periodic signals. In the next video, I will give you the example of periodic gate pulse. This is periodic impulses and we will also see periodic gate pulse, how you can calculate the Fourier series of a periodic gate. Okay, so I hope you understand the concept of impulse function, train of impulses, how you can calculate the Fourier transform of train of impulses by using the formula this. Why we are using this formula Cn and this? Because this is a periodic signal, and for periodic signal we have to calculate the Fourier series. So I hope all these concepts must be clear to you by watching this video. If you have any further doubt, you can write it in the comment section. Thank you for watching.